a quadratic function using horizontal and vertical shifts and flips. You want to be able to use horizontal and vertical shifts and flips. So if we're going to graph a quadratic function, we need to know what we mean by a quadratic. You should have notes up to 14. We've done notes 10, 11, 12, and 13. So we're going to be graphing today. So we need to know, what does a quadratic, what do we mean by a quadratic? Hey. So when we talk about a quadratic is a second degree polynomial. Guys, I need you to quiet down, please. I still hear too much talking. So a quadratic is a second degree polynomial. What do we mean by something that's a second degree polynomial? Liam? The highest exponent is 2. So when we have a second degree polynomial that is a quadratic, it can either have 1, 2, or 3 terms. Kevin, I need you to take your headphones out now. So 1, 2, or 3 terms. Sorry. The only important thing is that it has the squared. That's what makes it a quadratic. Okay. So second degree polynomial with 1, 2, or 3 terms. So before we go and graph a quadratic, I want to make sure you can graph the functions you should have learned how to graph last year. So a quick review, we're going to review how to graph a line. That one should be very familiar. You should have spent a lot of time graphing lines. And then graphing an exponential function. Michael, Kamal, Hannah. Guys, still way too much talking. So we're going to start with a line and review how to graph a line. So when we graph a line, we call that a linear function. In other words, a line. And when we graph the line, we usually use the y equals mx plus b form of a line. There's lots of different forms. We could have written ax plus by equals c. We could have written point slope form. But we're going to use slope intercept form. Guys in the back. Kayla, Jessica, Aaron, please quiet down. All I hear is a lot of giggling. These notes should not involve giggling.
Sorry, it's because I'm missing.
Okay, y equals mx plus b. What did m stand for and what did b stand for? One of us told us slope. One of them told us where we start. So what does m stand for? Is that slope or where we start? Slope. M is slope, which in other words is rise over run. So that means B is where we start. In other words, the y-intercept. That's the fancy math name. Y-intercept.
I looked away for 3 seconds.
Where we start. Where we start. So again, this should be review from last year. We're not spending a lot of time on this because it should be something you saw last year. So we're going to do one example where we graph a line. Y equals 2x minus 3. We need to identify slope. We need to identify y-intercept. and then we can graph our line. It tells us where to start and how much our line is changing.
Can you go back up, please?
Hold on 1 second. We might have to have a new seating chart if you guys can't quiet down.
Oh, I can't see.
Well, tell that to people who won't be quiet.
We're not problems.
Yeah, but I don't have enough spaces to move just the people who are talking. I have to move everyone. So, y equals 2x minus 3. We need to identify slope. We need to identify y-intercept. Which number is slope? 2. Just the 2. The x is not slope. The x tells us where the slope is, but it is not the slope. Now when we have slope, we must make it a fraction. So what do I put it over? 1. Which leaves the other number, -3, as b. And now we can graph our line. B tells us where to start. So it's kind of weird. We start with the right number. We start with -3 first, and we always start with it on the y-axis. That's why it's called the y-intercept. So we go down 3 to -3 on the y-axis, put a dot. For a line, we only need 2 points. 2 points is all we need to graph a line. So from there, we can do our slope. Our slope is 2 over 1, so it's telling us to go up 2, right 1. So we go up 1, 2, right 1, and then draw a straight line through those points. Okay. So it should be something you spent a lot of time on last year. It should be something you've seen last year. Graphing lines is a large part of secondary math 1. The other graph that you should have seen, but it's kind of a new addition to the curriculum, so I'm not 100% sure all the teachers taught it, is an exponential function. So, have you guys heard the question, would you rather take $1 million right now, or would you rather me pay you 1 penny on the first day, and then double it, 2 pennies the second day,
I take the second option.
double it?
I do the pennies.
The pennies the pennies end up being around like $18 million by the end of 1 month. It's something, is it like 10 or 18 million, somewhere in there. I've forgotten the exact number. So that's an exponential function. It gets big really, really fast. Growth, exponential functions are one of the most useful functions in finances. Calculating interest, you use an exponential function. Decay is often used in carbon dating. You know how they tell how old an object is? Well, that's the decay type of function. They figured out how fast carbon decays over time, and they can measure that information so that they can figure out how old an object is. So growth, today is October 7th.
After the note, should I go put this in my locker?
Growth, A is bigger than 1. This number we place here is bigger than 1. So 2 or 3 or 3.5 just has to be bigger than 1. Decay, this number is between 0 and 1. So again, these are just review of something you should have seen last year. We're going to only learn the most basic way to graph it. We're not going to spend a lot of time on this because our focus will be of quadratics. So when we graph an exponential growth and an exponential decay function, again, for our purposes, we're just doing the most basic. We are always going to start at 1 on the y-axis. just doing the very most basic version. So for our purposes, there are some variations, but we're not focusing on these variations because we're just reviewing this really quickly, and then we'll talk about graphing a quadratic. So for both of these, we always start at 1 on the y-axis. That's where we put our first dot. It's the same for both. But growth is getting big really fast, and decay is getting small really quickly. So growth, we're going to start low. We never go below the x-axis, so we follow along until we hit the dot. Then we go up really fast. Decay, we come down really fast, so we start high, go low, and go along. And those are just some review of functions you should have already seen. So our goal today is going to be working with quadratic functions. Remember, that was degree 2. Quadratic functions are used a lot in physics. If you drop an object or you throw an object, you can actually map the trajectory with a quadratic function. And we will do an experiment with that eventually, but we need some more information first. So does everyone have this down before I go to the next page? So there are some problems on the homework that are those review graphs. There's very few. There's only 4 total. But just keep in mind you will have to graph a line and an exponential function. So when we work with a quadratic, there's 2 main forms we work with. Yeah. The first form is called standard form. Y equals ax squared plus bx plus c. They each have their own uses. This one's more useful for solving quadratics. We will learn how to graph it eventually. But we're going to start with this vertex form. Y equals a times x minus h squared plus k. Vertex form is our best one for graphing. This is the one that will make our lives easier to be able to graph. So when we graph a quadratic, first we need to know what the picture is going to look like. Right now we don't. So we have to get an idea of what does a quadratic look like in general. And then we use something called the parent graph. And that graph is what we base all our other graphs off of. Our parent graph is the most basic form. And then we're going to move it around to find the other graphs of a quadratic. Did you not get the entire?
No. After you go to back. What does the other one say? On that side?
Vertex form. So are we ready now? Okay. So this is the most basic graph. Y equals x squared. We don't have anything else but the x squared to tell us, hey, this is a quadratic. Oh, let's just pass out there for a second. Over there. Good? Maybe it's because it's so hot.
Can I go talk to everyone now to see if they can turn off the heat in this room? Because I am like.
They already talked about it in faculty meeting that we had this morning, and they cannot do anything about it right now. So.
Can I go work out the hall?
Yeah. So, parent graph. Right now we have no idea what this looks like. The best way to figure out the picture of a graph is to make a table. So we're going to make a table and see if we can get what the quadratic looks like. Right now we have no idea what the picture of this graph will look like. So we're going to pick our x values. We're going to pick -2, 1, -1, 0, 1, and 2. We're going to use those points to graph this function. If I have x values, how do I find the y values? How do we use the x values to find the y values? Liam said use the x values. How do we use the x values to find the y values? What can I use?
Yeah, you square.
Why would we square them, Dylan?
Because x squared equals y.
X squared equals y. So if I go y equals -2, I replace x with the number we're working with at that time. So I replace x with -2. Now I put it in parentheses for a reason. When we square something, our calculator knows order of operations better than us. It won't include that negative in the squared unless we put parentheses around it. So if we do -2 squared, -2 squared is -2 times -2, which is +4. Now we do not have to do the table on the assignment. The whole purpose of this table right now is to give us the picture. So we only are doing the table once, and then I'm going to show you how we can use that information and not have to do a table for the rest of them. Then we get -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So we've made a table so that we can plot these points and get an idea of what this graph will look like. We know what a line looks like. It's a straight line. We know what an exponential function looks like. Dylan and Nick, please quiet down.
You start with x, right?
Yep, we start with x. So when we graph these points, we start with x. X goes left or right first. So we go left 2, up 4. There's my first point. Then we go to the next point, -1, 1. We go left 1, up 1. Come on, write it down, please. We go 0, 0. That just stays in the center. 1, 1, and 2, 4. So this is what the picture of a quadratic looks like.
Oh, whoa.
We can't use straight lines because if I did a straight line, it wouldn't hit all the points. We have to curve it. It looks kind of like a U-ish shape. A parabola kind of looks like a U. So just like a line has slope, this has slope as well, but the slope is changing. I usually call it the slope pattern because it's not really a slope, but I just say m equals so because we can associate it with a line. When we identify the slope on this bottom point is the most important point. We call that the vertex. So we always count our slope from the vertex. So if I went from this point, how far up and how far over do I go to get to the next point? 1/1. Now we notice though that this repeats on both sides, so I would go up 1, left 1. That also gives me a point. So 1/1, we use it twice. What about to this next point? Again, starting from the vertex. How far up and how far over do we have to go? 4/2. So that slope pattern is going to be very important in our graphing. This can replace this entire table, mostly. So we know that it's supposed to look like a U now. We know the slope pattern now. So now we need to figure out because we can actually shift this graph around. What's going to happen, let's see if it'll let me do this. Yeah. We're going to actually shift the graph around. We're going to move it to the left or move it to the right or move it down or move it up. We're shifting this around when we're graphing. So another word you might hear me use is parabola. I use the word parabola and quadratic interchangeably. They're about the same thing. But a parabola is the picture of a quadratic. So a parabola is a picture of a quadratic. And I will use, again, that word interchangeably. I might say parabola when I'm talking about a quadratic. So now, we need to know, how is this graph going to shift around? We know the slope pattern. We know what the basic look of it is going to be. So looking at this y equals a minus h squared plus k, we're going to pick one of these things to change. We're going to get rid of the rest. So we know we have to keep an x. We know we have to keep a squared. But I'm going to get rid of a and h right now, and I'm just going to do k. I'm going to focus on k, and I'm going to see, what does that do to my graph? How is that going to move it around? Because this number here will tell me some information we need to know in order to graph. So this is where we need our graphing calculators. We're not logged in, but we can still use them for what I want. So does everyone have the a minus h squared plus k written down? Okay. We'll come back to the notes after we graph. So I need so if you're not already at the home page, hit the on button and it'll take you to the home page. Or if you're in a screen, you might have to hit escape to get out of whatever screen you're on. So everyone should be at this home page right now. We want to create a new document. So we're going to either hit 1 or you can scroll over. We're going to create a new document, 1. And we're graphing, so we want to add a graph. So number 2 is add graphs. Or again, you can scroll down and hit enter. So you should be at this page. Is everyone at this page? So we need to graph our parent function so that we can compare all of our movements compared to our parent function. So we're going to graph x squared. X is at the very bottom on the keyboard. And then squared is 2 below the blue control button. So we're going to hit x squared and then we hit enter. It's going to show that graph. So all of our movements will compare to this graph. So now we need a second graph. So we're going to hit tab. And that brings up the ability to graph a second graph. So we hit the tab button, it's above the blue control button. And now we're going to pick how to change this function. We're still going to use x squared. But now we're going to add a number.
Mine has writing in it. Adding squared.
That's why we wanted to start a new document. Yeah, we want to do. So, what do we want to add to this? Can't be more than 7 though. Any number. 4 plus 4. So now we're going to see, what does this do to our graph? Does it move it up, down, left, right? Does it switch the size of it? So what happened when we added 4? Moved up. Why do you think it moved up? Okay. Because the 4 is positive. We moved up further on the y-axis. So what do you think happens if we do a negative number? Okay, so let's check. Hit tab again. A negative after, not before. So it automatically comes up with a different 2, but I had graphed 2 different ones. First I entered in x squared, then I hit the tab button and entered in x squared plus 4. Now let's do x squared minus 3. We predict that this number is now going to move it down. So did we move down now? So we have a pattern. The pattern is if we add a number, we move up. If we subtract a number, we move down. So let's go back to our notes and write this pattern down. We call this a vertical shift. So this number k on the outside we call a vertical shift. I usually write VS for vertical shift. And now we know if k is greater than 0, so if k is positive, let's write if k is positive, that will be more understandable in your notes. If k is positive, move up. If k is negative, move down. So if we add a number to the right, outside of the parentheses, or if there are no parentheses, just to the right, then if k is positive, our graph will move up. If k is negative, our graph will move down. So now we have to check what are some of these other ones going to do. So let's change h this time. Let's see what happens when we move, or when we change that number. So again, we go to our graph. I'm going to pause for a second to make sure everyone has this written down before we go back to our graph, though. So now, I don't want these graphs anymore. They're going to get in my way. It's going to be confusing. So we're going to create a new page. We're going to hit Control, Doc. It's going to add a whole new page. And we're going to add another graphs page. So I hit Control, Doc, add another graphs page. I still could go back to my other one. It's still there. If you look at the tabs at the top, we have 1.1, 1.2. But again, I want to first start with just graphing x squared. So right now, all we're going to type in is x squared. We want to graph that only so that we have something to compare to. We have to know where we're starting to see how something changes. So there's our parent function. It's the most basic quadratic graph. We hit Tab. Now this time we're going to involve our parentheses. So we hit our parentheses, we hit the start parentheses. Notice they've already put the end parentheses. We're actually not going to have to hit the parentheses button again. So we hit x, let's do -2. It already has an end parenthesis, so we don't have to hit it again, but we need to move outside of it, so we hit to the right, so that we get outside of the parentheses. And then we hit squared. So again, we're trying to see how does this change our graph? What kind of movement? Do we move up? Do we move down? Do we move left? Do we move right? So we hit enter. And what just happened? Which direction did we move?
Right.
To the right. Now, is that what you expected when we have a minus here? What does a negative usually mean when we move on the x-axis?
But it's
Usually
squared, so you
goes
can
to
do
left.
that.
Kind of. There's not a great explanation I can give you for why this happens without delving into a lot deeper mathematics. So, just know it's opposite of what we expect. This -2 actually moved us to the right. So what do you think a positive is going to do?
To the left.
Probably to the left. So let's check. We hit the tab button. Let's go x plus 5. Again, we don't have to hit the end parenthesis. It already popped up the end parenthesis for us. We hit enter. And did we move to the left like we predicted? Yes. So now we have a pattern to follow for, I was putting the two words together, follow for became follow. Follow for horizontal shifts. Negative moved to the right, positive moved us to the left. So horizontal shift. If H is positive, we actually move left. It's opposite of what we expect. H is positive, we actually move to the left. If H is negative, move right. So it's opposite of what we expect. A negative value actually moves us to the right. A positive value moves us to the left. And that's the number inside the parentheses. H was inside the parentheses, not outside. K is the number outside. So the last thing we want to worry about is we're not going to do A fully today, but we are going to see what happens when we put a negative in front of the entire equation. So we're going to see what we do when we get a negative. Yeah. So we go back to our graph again. I'm going to get a new page so that I don't have so many things going on. This time, let's not graph the parent function. We know it starts in the middle. Let's just graph negative x squared. Negative x squared. Lacey, Andrew, Darius, please join us. In other words, wake up. Wake up.
It's too hot in here.
It is. But we have to stay awake anyway. Darius, wake up.
I'll just take a break.
Can't take a
Wake
Wake up.
You can massage them with your foot, but I can't.
Lacey, stay awake. Okay, so we put a negative in front of our graph. We hit enter. What happened this time? It's upside down. Okay. So we put negative x squared instead of x squared. It flipped our graph upside down. So we have a flip if A is negative. So that's all the information we need to be able to graph these. Now our ultimate goal is to graph them by hand, not with the graphing calculator. Yes, we could graph them with the graphing calculator, but we want to know how could we do this without the graphing calculator. We do. So let's look at this example. F of x equals x minus 5 squared minus 1. F of x is just another way to say y. It just means the same thing as y. So we're going to graph this function without our graphing calculator. So we draw our coordinate plane, or Cartesian plane. You can call it either. And I want you to actually label the information we need. We're not just going to graph it. I want you to tell me, what is the horizontal shift? What is the vertical shift? What is the slope? Do we flip? And also some information we haven't talked about yet. We're going to name the vertex. And if we have a max or a min. So the graph is provided on the homework. The stuff on the side you're going to have to write in. wasn't a good way to include it on the program I used to make up the assignment. So, we need to label this information in order to graph first. And what we need to start with is horizontal shift, vertical shift, and slope. So horizontal shift was given by the number inside the parentheses. This number here. And we looked at the sign. Does it tell us to move to the left or to the right? If it's negative, we move to the right. So you're actually going to write down right 5. Or if you'd like to use an arrow, I would also accept that. But I will not accept negative 5 because I don't know if you know negative 5 means move to the right. So you're going to write the words right 5 or put an arrow 5. Arrow going to the right. Okay, what about the number outside? So inside was horizontal shift, outside was vertical shift. Is that telling me to move up or down? Down when it's negative, down 1. If there's no number in front, our slope doesn't change. We're not really going to talk about the slope changing until next time. For the most part, our slope is always going to be 1 over 1, 4 over 2. And that's really more of a slope pattern than a slope. So the 1 over 1, 4 over 2 is something you need to have memorized basically for now. And then flip. It only flipped if there was a negative in front of everything. Is there a negative out front? No. So there is no flip. So now we use these movements to draw our graph. We say right 5, down 1. That means from the center, because that's where my parent graph's vertex started, I go right 1, 2, 3, 4, 5, down 1. There's my new vertex. That's my main point. Andrew, Ayla, pay attention please. So right 5, down 1. From there, I use my slope. Just when you draw a line and you start with the starting point, and then you do your slope, same thing. This time, though, our slope is actually 4 different things. We have to go up 1, right 1, up 1, left 1, back to center, up 4, right 2, up 4, left 2. So from here, we go up 1, right 1, back to the vertex, up 1, left 1. But that's still not enough information for a quadratic. We still need the next 2 points. So from the vertex, we count up 1, 2, 3, 4, right 2, up 4, left 2. And it should be curved, not straight. Curved, you wish shape. So now that we have the graph drawn, we need to answer our other 2 questions. The vertex is this main point that we count the slope off of. It's either the bottom of the graph or the top of the graph. So when I want you to name the vertex, I want you to give me the actual coordinate. What is the actual coordinate for this point? 5, negative 1. We went right 5, down 1. Coordinate is 5, negative 1. Now, if that vertex is the bottom of the graph, it's a minimum. If the vertex is the top of the graph, it's a maximum. So which one do we have? Minimum. So now we are finished with this problem.
Where'd the 4 over 2 come from?
4 over 2 we got from, I'm going to flip to another page. We got when we drew this parent graph and we made the table to get it. We said, well, these points followed the pattern of up 1 over 1. And then the other 2 followed the pattern of up 4 over 2. So it's something right now you just have to have memorized. Nope. Okay.
Can we go back to the Can I go get a drink, please?
So we have one more example and then I'll pass out the assignment. Are we ready to move down to the next example now? Okay. So to make sure everyone was caught up. So, last example. Again, we have to write in all that extra information. We have to write in horizontal shift, vertical shift, slope, flip, vertex, and max min. And then we also need to draw our Cartesian plane. On the homework, the coordinate plane will be given for you. You will not have to draw it every time. But then we have to fill in all of this stuff on the side. Vertex and max min. So again, we have to identify what's our horizontal shift, what's our vertical shift, what's our slope, do we flip or not? So yes, if you have a graphing calculator, you can use that to check whether you're correct. But if you're not writing all that information on the side, you're not going to get full credit. So horizontal shift was the number inside of the parentheses. What number is inside the parentheses? The +2. Now what direction does that tell us to go? To the left. So remember, we have to write left 2. I don't want just the positive 2. I want to know what direction should you go. What about the vertical shift? Vertical shift is normally the number outside the parentheses. Okay? Stays the same. In other words, no vertical shift. None, or you could write 0. Our vertical shift doesn't happen. There is none because there's no number written there. Slope. Well, this time, since we're going to go down instead of up, why are we going to go down instead of up? There's a negative out front, so yes, we have a flip. This time, since we're going down instead of up, we should put -1/1, -4/2. Because we're going down, not up. If it was positive, it tells us to go up 1/1. If it's negative, it tells us to go down 1/1. Just like the slope of a line. So we have to graph before we can write in the vertex. So starting from center, I go left 2. I do not move up or down, so I just start left 2. My slope says to go down 1/1. So from this dot, I go down 1, right 1. It has to repeat on the other side as well, because that's what a quadratic looks like. Quadratic repeats on both sides. And then from the center again, from the vertex, we go down 4/2. Down 4, left 2. And once we have our graph drawn, now we can graph our vertex and our max or our min. So what's the vertex on this graph? What's the actual coordinate of my vertex? -2, 0. Do I have a maximum or a minimum? Max, because it was on the top of my graph. So remember, on your assignment, the first 4 are review problems.